Hello everybody! Today I want to teach you guys how to create 3D printable objects. Basically, how to design an object that is 3D printable. I want to show you guys how you can bring your idea to life using Rhino 3D. I personally choose to use Rhino 3D instead of using Fusion 360 because I think Rhino 3D is much nicer to use. You type in the commands, a lot of the things don't get done through user interface, but rather through typing. You just need to remember some simple commands. I think for most beginners, Rhino 8 is much easier to use than Fusion 360. I will also show you guys how to make sure your 3D prints can print without supports, how to avoid any overhangs. And along with this, I'll also try to teach you some good beginner tips to help you guys get clean and good 3D prints. So let's get going. Let's look at the project. Let's look at my idea and what I want to bring to life today and follow along. And maybe you guys will be able to create your own 3D printable objects very soon. Let's talk about my idea. To be honest, this isn't a new idea from me. I've already come up with this in the past. I've used this object for a long time. It's been super useful. So here's my idea, which is a kitchen bin. Basically a bin that you hang onto your kitchen counter so you can have it right next to your slab and you can just push the vegetables into your bin. It's just a small movable bin that's for the kitchen. I've used a kitchen bin in the past and it's been revolutionary for my kitchen work. So watch me as I create my idea. But this video isn't about kitchen bins. This video is how to bring your idea to life, how to create a 3D printable object. And I chose to use the kitchen bin because I think it's a very good beginner's point. It's just a square-shaped object that has some specific features that help it attach to my counter or the door of my kitchen counter. So, my kitchen bin. Basically, there's going to be a little arm that will hold onto the door with gravity, and there will be a bin. It's a very simple shape. I can put trash into the bin, and that's it. The only thing unique I want to do is have this printed in 2 pieces. So the bin itself is 1 piece, and this arm attaches to the bin. I will do this by creating a lock mechanism, sort of like this, and this piece will just be a stick. I will talk more about why I'm doing this while I'm creating this piece, and same for the kitchen bin. So it's a very simple idea. Let's see it come to life. So the first thing you have to do when you're using Rhino 3D is create a new model that will open you a new file with 4 windows. Now, I personally don't like to work on 4 windows at once. Some people might just use it to inspect the different angles of the object. But to get into one single window, you just click maximize over here, and then you have a single window. Now there are 2 things to remember in Rhino. It's very simple. With AutoCAD 3D, you draw things usually on a sketch. Here you draw things using polylines. So I can, for example, draw a rectangle. Well, first let me show you what a polyline is. Here I can draw a polyline. Now, the polyline you can bring into any direction, but if you hold Shift, it's going to try to go at 90-degree angles. I want a box, and before I create this box, I need to know what dimensions I need. So let's quickly go measure the dimensions of my kitchen drawer and see how big I want my bin to be. I don't want the bin to be longer than 1 drawer, so I want to be able to open up the drawer below the kitchen bin without a problem. So I need to measure out the height of the drawer, and I need to see how wide the doors are on my kitchen counter. So my drawer is 195 tall, so maximum 190-ish. And the width doesn't really matter. I can make that the maximum that my printer will do. So let's go. My print bed on the P1S is 256 times 256, but I can't print on the whole print bed. So my dimensions are 250 wide, 200 in the other direction. So I have some space for the exclusion zone on the P1S print bed. Now, On Rhino 3D, to create this object, I can do either a rectangle, which is 250 times 200. Then I just get a rectangle. Then I can click on it and type in extrude, curve. Now I am extruding this curve and I am creating a three-dimensional box. Now I need to decide the height, which was 195. So I'm going to type in, to give some tolerance of 5 millimeters, I'll type in 190. Now this is my kitchen bin's shape. As you can see, it's see-through, so if you guys want it to be shaded, you can press shaded. This is what it should look like. This is the box and this is the line. So you can see you're working with lines that you're drawing and you're extruding these lines. You can as well click over here onto box, type in 250 times 200 and extrude it by 195 and it would do the exact same thing. So let's continue working with our shape. So now that I have this box, I need to decide what is the wall thickness of my object. Usually in 3D printing, anything below 1.5 millimeters of wall thickness is not very sturdy. I usually go with one line is 0.3 millimeters. So if you want some tolerance, 0.3 millimeters is generally a good tolerance to get one line of thickness less, and it will definitely give you enough space between objects so that things can fit into each other or so on and so forth. Now, what I want here is a very strong wall because I don't want my kitchen bin to break. I have in the past printed it with 1.5 millimeters and that lasted for over half a year, but I will be printing it today with some stronger filament than PLA and I want some stronger walls. So I want to use 2 millimeters, maybe even 2.3 millimeter walls to have some very chunky walls. So now this is how I can create a hollowed out object in Rhino 3D. This command is almost the same in Fusion 360. Most of these commands are in fact almost the same in Fusion 360. So what I do in Rhino is I type in shell. Every time I type in a command, up here, you guys can see there's a window of all other possible commands. I want the shell command, so I'll use that. But Rhino makes it much easier to find everything because you just type it in and it's there. So, shell. Now I choose which side I want to shell. I could, for example, shell this front side and this side. Now that means it would create me like a tunnel that goes through. As you guys can see, that's a tunnel. But that's not what I want. I want a bin. So I type in shell and over here you can see the thickness of the shell. As I mentioned before, I want 2.3 millimeters thickness. So I type in 2.3 over here. Now I decide what side I want to have as the opening. And this is my opening. If I press enter, it will create me a nice box with 2.3 millimeter walls on each side. So enter. There you go. This is very nice. I like this a lot, but I want to make the design a little bit nicer. So I'm going to round off the edges. So let me go back before I shelled it because rounding off the edges after I shelled it can cause issues. Let me show you what issues. So you type in fillet edge to round off the edges. And I want to say fillet my edge by 10 millimeters, which will give me a 10 millimeter curve radius. If I fillet this edge, for example, this side will try to go through this area. And you don't want this filleted edge to go into a negative space. You want it always to be solid. So you want there to stay. You want here to be some gap. So the only way I could fillet this is by filleting both sides. Because now you guys can see there's a nice line over here that can fill out like this. But the way I prefer to do it is fillet the edge before. So now I'm back to the beginning. I didn't shell it yet. And now I can fillet the edge and play around with the shape a bit. I want the back just to be straight because you don't usually see the back. So maybe there's a little fillet of like 4 or something. So this side will be facing the counter. Like over here is the counter. Now here I want a big rounded edge because I think it will look nice when you walk by and there's a rounded edge. So I do again fillet edge 10. I think this fillet is too small, so I'll do fillet edge 20. There, that looks pretty nice. Now, one thing we want to make sure is we don't want to fillet these edges, because you have to remember this is 3D printing and you want the bottom to be as flat as possible. If I fillet these edges, this will, well, first of all, this doesn't work, but that's because I filleted this little piece. But if I fillet these edges, this might look nice to you, but it's not 3D printable because this overhang over here is greater than 50 degrees and it just cannot print in mid-air. It's going to fall due to gravity. So if you wanted this sort of shape, you would have to chamfer the edges and not fillet the edges. You can do this by typing in chamfer edge. Two things. Now I could chamfer the edge by 20 and that would give me this. This is 3D printable because here each layer is building up on the last line. So usually overhangs that are around 50 degrees are still 3D printable. So this would be perfectly 3D printable. Now this is not what I want, so I'm gonna go back to what it was like before. As you can see, a perfectly flat bottom. The edges over here are not pointy. And I'm doing that because if they're pointy, they're more likely to lift off the bed and warp. So that's why I also gave a little rounding on the back side, even though I don't necessarily need it. Now back to shelling the object. 2.3 millimeters thickness. That should make it nice. In fact, I'm going to make it 2.5 millimeters thickness. Chunky. Now, I already created this piece. Now comes the challenging part. Creating this piece and creating the attachment mount. The challenging part about this is creating it in one piece without ever going against gravity. So as I just taught you, you don't want to create rounded edges here because you're going against gravity. Same thing will be when I'm creating an attachment point. I'm going to be creating it on this wall over here. And because it's on this wall and I'm printing it in this direction, anything that comes out here will be going against gravity. So I want to be doing it at a gentle slope, at a gentle angle, so the lines can always build up on each other. Now, the way I do this is I like to start at the midpoint. I hold shift so it's 90 degrees. Now I can create a line. I personally don't care right now how large this holding piece is for the handle that will go over the door and hold the entire bin's weight. But it should be chunky enough, so let's make it there, 40 millimeters. Now I have a line that goes straight down. Again, I held shift, so it's 90 degrees. Now I can hold shift again, and it's going 90 degrees in this direction. It doesn't need to be a very big object, so I will do 25 millimeters. Hold shift and this. And now I can create a perpendicular line holding shift or not holding shift up to here. Bam, enter. Now I have this object. Now what I want to do is over here have a mounting area. Whoop. You have to be very careful when drawing these lines because sometimes random things happen. You want a mounting area over here, right? And now the problem is this is just hanging out vertically. So this would slope down and fight gravity. So what I want to do is make an internal support. That's why I'm drawing this triangle from here to here, because this can now print again, layer on layer like that. So now I have an object that I can attach to my wall, hang it mid-air, but I don't need supports. What I just did was retrace the outline of this shape so I can extrude it. So I take the outline, see this is the outline of my shape that I just created. Now I can extrude all the way to the end and now I have a shape. You might not yet fully understand why I'm doing this, but I hope you're understanding how to create these shapes and why I would create a triangle shape instead of just a line that goes out, because again, gravity would pull it down. See, there I have my shape. Now, this is a nice and chunky shape. And I can now take this shape and, well, before I move it and copy it and do multiples, I'll go back to the shape. Now, as I drew over here, I want an attachment point that is circular. So what I'll do is I'll create a circle. There you go, you can see a circle. I want a relatively big and thick attachment point. So I'm gonna make the circle almost maximum size. Let's quickly look at the size of this. 16 millimeters. So one suggestion from me is, if you're trying to create 3D printed designs, pick up a caliper, then you can accurately view these measurements. 16 millimeters, that's this big. So now I can see, is this too big? Is this too small? I think this is just the right size to make a chunky attachment point. Now, I like this circle size, it's good. Now I can rotate it. How do I rotate it? I press an object and usually these lines come up. I can click it. Now I can see which direction I want to rotate it. I want to take this circle and rotate it so it aligns onto this side. Whoop. Now I rotate it 90 degrees. There you go. Now you can see they align. I can take the circle and move it down up to here. Here I already have a pretty solid shape, but I don't like these pointy edges. So what I want to do is also remove them. Now if I want this on both sides of this object, I can click it and mirror. Now mirror along which axis? This one. Here, this is the midpoint between this and where I want it to be. So again, mirror. Whoop. Now I can take the push and pull, and I can just select all these surfaces by holding the control button, I think. My keyboard is mapped a bit differently. Now you guys can see there's a bit more of a edge that is holding the circle. I'll show you offset. And now, as I said before, one line is usually 0.3 millimeters. So if I want a tolerance for something to fit through another object, like a circle that fits through another circle, then I need to do 0.3 millimeters, and usually that will be perfectly fine. 0.3 millimeters, and now I can take this. So what I just did was I took the circle, and you can offset any shape and you can make it bigger or smaller. So I'm taking the circle, and for example I can offset it by 10, and now I'm going to have a large circle. You see, a huge circle. Or I could offset it by 10 inwards, but then the circle simply doesn't exist anymore. What I did was I offset it by 0.3 millimeters, the width of exactly one line in 3D printing, at least with a 0.4 millimeter nozzle, which will give me enough tolerance for one object to fit through another. Extrude. Yeah. So now you guys can see, if I would have this circle and stick it through this hole, I could not pull it up anymore because it would collide over here with these edges. So I can now stick the circle in, and I can't pull it up. I can only pull it out in this direction. So now I can make my hinge that goes over the kitchen counter's door. So the hinge goes over the kitchen counter's door and holds the bin down by gravity. By me just pushing the pin through, by me just pushing this through the hole. Now you might ask, why am I not doing all of this in one piece? There are two reasons for this. The first reason is it's much easier to print complex shapes if you can print them in two separate pieces. In this case, this shape, I can print it very easily, thick and chunky in one shape and quickly by just printing it separate. The second reason I'm doing this is because I want my large bin to have a nice blue color, but I want my hinges to be as strong as possible. So I will be printing the hinges in PETCF, a super strong material, a material I'm sitting on my chair right now. And I'm going to be printing the bin in a nice, colorful carbon fiber PET in blue. I will also add some accessories, but I'll show you that in a second as well. Now let's get to finishing off this hinge. So I have this piece of the hinge, and these are now two separate pieces. I have my tube and I have my piece that's like attached to the bin. So my bin is here, and this thing will be printing together with the bin in one piece. And my hinge is a separate piece that I will be printing, and I can just stick it in without gluing, without magnets, without any extra work. I just stick it in and it should hold perfectly. So again, here's my hinge. Now what I want is basically this. Mirror this along here. Take this. Now, let me show you how to combine objects to not make it too complicated. So I can first type isolate on these two lines, and I want this to be one line. So what I do is select them both and I type in trim. Now I can trim out the lines I don't want. I don't want this line and I don't want this line. Now I can press enter and this is my final object. Now they are all individual pieces, so I want to join them. So I press join. I type in join. Boom. Now this is one nice smooth line that I can extrude. So I type in, by the way, if you highlight objects and type in hide, they hide. And if you type in show, everything shows again. So hide. Now I can work on this. I can hide this. This is one of the big reasons why I prefer Rhino to Fusion 360, because Fusion 360's interface is in my face and clunky, and here I can just, with one command, hide, show. I know it's possible in Fusion 360, but is it that easy? If it is, tell me. Now I can extrude this piece and done. Now what I really want is my hinge to go over here. The maximum thickness I want for my hinge is 5 millimeters, I believe. Or wait, it's a question. I think I left 5 millimeters space before, so I made it 190 exactly. You guys can see it's 190. So this thing can be 5 millimeters tall. So what I want to do is press it and pull. And I can now pull it down and I can see it's 3.46 already. So now 5 minus 3.46 is equal to 1.56. So 1.56, and I will add it. Now this is exactly 5 millimeters. My math was off, 0.02. I pull it down, now it's exactly 5 millimeters. So this is the final height I want, and all I want to do is take this thing, make a line and move it down by, remember the threshold I like to keep, 0.3 millimeters. So 5 millimeters minus 0.3, move it down by 4.7 millimeters. Now that I have this line on the surface, I can push and pull it. So I will first push and pull it to the same distance. As you can see, there's a nice thing here. Now, the next step is I need to know the depth of my door. The door is 2 centimeters, 20 millimeters. Yes, I know for you Americans this video is awful. I'm sorry, but it is the way it is. So we do 20, as you guys can see, it's flush right now. So 20 millimeters. Now we are at the end of the door. Now we want to go down. Another important thing is this piece, it's not allowed to be wider than the gap between the drawer and the top of the counter. So I need to check what is. Yeah, it's maximum 5 millimeters. I think 4.5 millimeters is safer. This is another reason why I need 2 separate materials, because 4.5 millimeters is not a lot. So this material needs to be very strong. So we're at 4.7, 4.5. All right, we're gonna do 0.3 less. So we're gonna do 4.4, give it a little bit of tolerance. You know what? No, 0.4 less. 4 millimeters. It is what it is. It's all I can offer. So this piece should now fit through the slit of the door and be able to go to the back. This is the right length. So all I want now is just to create a box. Create a box. You know what? I'm gonna do 5 millimeters extra. I will dupe this line. I will move it by minus 4.5 to give it some tolerance. I like to always give everywhere some tolerance. So tolerance towards the end of the door. And I'm gonna pull this down by, I actually do not care how much. There. That's it. As you guys can see now, this thing should be able to attach to the back of the door. No problem. These hinges are how small they are. Very small. These are very easy to print. You can just print them. As you can see, there's a flat piece here. This is where they're gonna lie on this face. So it's going to be standing up on this face. Nothing will be hanging. See, this is how it's going to be standing. So nothing will be hanging because of gravity. It's just print in one piece, very easy. You can print it with any material, which is important because this piece will be printed in a strong material, in a very strong material. Now, I don't think one of these hinges is enough. So what I want to do is create multiple. But before I create multiple, like always, I want to make the hinges look a little bit prettier, look a little bit nicer. So I will isolate these pieces and I will, well, do some chamfering and do some filleting. So let's start with filleting some edges. I want to fillet this piece over here by 3. This one is nicely filleted. It can now slip more easily under the counter because it will go in and out and in and out. So if it's going down, it will more easily slip in. Now I can also fillet this piece. Whoop. I could fillet these 2 pieces. See, this is, I cannot fillet them more than the distance. I'll show you. So this distance is 4.5. So if I fillet them more than half of this distance, they will overlap. So you want to only fillet them to the half maximum. So what I want to do is 4.5 divided by 2. I want to leave it maybe a little bit of space. So that's, let's say 4.4 divided by 2 is 2.2. Now 2.2, I want to fillet them by 2.2. Smooth, it's smooth. And then I want to fillet this piece too, but not by much, honestly by very little. So I will fillet this piece by 1 there. So now I got a nice rounded piece. Now I can hide this piece because it's no longer relevant. Now this piece is the next piece that's relevant. Everything should print fine. This piece is flat on the wall, so maybe I can fillet this edge. A small amount of fillet wouldn't make much of a difference. And I can fillet this edge over here. Aside from this, I don't have a problem with how it looks, but I want to do one last thing so that these hinges are good quality. The problem is I don't want the hinge to slide in or slide out, so I want a way for the hinge to kind of hit a barrier at least, so you can slide it to an end point and it won't slide much further. So I'm gonna add 2 millimeters to one side of the hinge. I'm gonna dupe this face, add a line here, then select that line, isolate, and then trim. Now join, now show. Now I can take this and I can extrude it by 1.8 millimeters. There. Now I can just take these 3 objects, isolate them. Now I want these 2 objects to be one object, not this hinge, only these 2. So I Boolean union them. Boolean union just turns everything I selected into one object. So boom, Boolean union. And now I have one nice clean object with a dead end, so I cannot push this further. I could now do other things to keep the hinges in place. But in my experience, I don't need to. They'd stay in place by themselves. The only time they would maybe fall out is if you take the kitchen bin off and shake it to get the trash out, but you shouldn't be doing that anyways. You should be having a bag in it. Anyways, so this has a dead stop. It can't move up. It can't move in this direction. It can only move in and out in this direction, which is exactly what we want. Easy to put together. Easy to print. Now, I can make multiple copies of this, and that's basically what I'm going to do. I want to take one here and mirror it. And where do I want to mirror it? Along the center of this trash can. So, boom. Now you can see I have one on each side. And then I also want to take one and I will move it. I will move it. Move it from here to, no, that's mirror. I'll move it. So move it from here to, whoop. Okay, this will be easier if I clean this thing up a bit. So let me hide everything that I want to keep and I delete the screen. Show, no. I could take this thing again and move it. When I move, I select from where I move it. Here I want to move it from the center of the object so that I can perfectly move it to the center of the trash. Whoop, center of the object and center of the trash. Now I need to make sure it's on this side of the wall and not on this side. So I will move it until I see midpoint. There's the midpoint. Damn. And now I can take it and I can type in move, but I can click vertical. Now I can move it from the same position, but to the vertical position of this. So now they're at the exact same position. No. So now I have 3 hinges. One slides in from here. One slides in from here. Remember, when you mirror, the object itself mirrors as well. And one slides in from here. So all I need to do is print 3 of these and 1 of these baskets, and I have my kitchen bin. The only thing else I would like to add to my kitchen bin is make it a little prettier. I want to make the kitchen bin blue, but I want to add some extra accessories, make it prettier. And since printing in multiple colors takes a lot of time, I'm just going to add accessories that you can glue on, but you could also maybe make them to slide on. What I want to do is have my blue bin with some nice brown lines on the front and on the side. So how would those brown lines look? I would take a little box, I would, whoop, yeah, they don't need to be big. I just want some lines like this, but I want them to be indented. So I want it to be, yeah, sort of like this, right? So this whole bin is blue, but there are brown lines going on the outside like this. So how I do that is I will mirror this one, and I have another one. And I will take this line, I'll make a copy and move it out, rotate it by 90 degrees, and then move it from this top corner to this line. There, now you can see it's on this wall, and I want to make second one. This one doesn't need any math or anything behind it, just, you know, some fancy lines basically. Maybe I'll mirror it so it's even there. No, mirror, that's it. And now I can take these two, and now I can mirror them along the center of this, and now I have lines on all sides. Okay, so now what I want to do is take these lines, copy them, and then type in Boolean difference. Now I want to take these lines out of the geometry of the bins. So now I want to copy all of these things. Take this, type in Boolean difference, and select all of the sides. Now you can see they are cut out. You can paste them back. Now what I want to do is, since they're the same size, I will just add the tolerance to 1, add a little bit of tolerance, 0.3 millimeters to each side, so make it a little bit thinner. And that's it. That's my kitchen bin. 4 stripes, hinges, and everything else. I hope this video could give you some tips and tricks. And now let's get to printing, and let's show you guys the results and the function of my kitchen bin.